Hello everyone, this is Module 1 and Part 1 of Chapter 1, the introduction to our book that we'll be using for the CS 3410 class. Again, this is the 14th edition of Cronky and Hours database processing book. Chapter 1 objectives that we'll be discussing in this lecture is to understand the importance of databases in the internet and web applications. We want to make sure that we understand the nature and characteristics of databases, interesting database applications and stuff that are used with databases, how, just making sure that we have a general understanding of tables and how those tables have relationships with each other. And then we're going to spend a good deal of time in Chapter 1, really all of our time in regards to the assignments and the labs utilizing Microsoft Access and explaining some of the different functionality within Microsoft Access. And then we'll talk about the components of the enterprise class database system, which we'll be using later on in this class, which is, for this particular class, will be SQL Server 2012 or 14 Developer Edition. So we'll be doing some assignments with utilizing that application. But we'll also talk about the components of just in general of enterprise class database systems that will include IBM DB2 as well as Oracle and so on and so forth. Some of the last objectives that we want to make sure that we talk about is we want to make sure that we understand for this chapter what a database management system is and describe its functions. Understand the term and define the term database and what's contained in the database, as well as understand what the term metadata is and how metadata plays a role in our database management system. The class then will get into, Chapter 1 kind of gives you an overview of how this class is designed, which we'll spend a good deal of time discussing database design. And so Chapter 1 kind of gives you an overview of how we would do database design from existing data, how we do database design for new systems development, and then database design redesigning a database. So from some database that already exists, but we're going to redesign it to make it more efficient. And then lastly, understand the history and development of database processing. All right, so that being said, let's get right into it. Chapter 1 kind of starts off discussing the importance of how database management systems play a role in our everyday lives now. Because we're so internet driven, the use of web applications and smartphones that are illustrated here are examples of devices used by people who are referred to as the users, obviously, and then the client applications that you use on those devices, whether it be web browsers or apps or client applications, use databases to help facilitate, our searching, our browsing, whether we're doing online purchasing, if you're using Twitter, tweeting, Facebook, whatever. Typically, these services on the back end of your phone, smartphone, or computer, or web application, or whatever, are served by databases containing data needed by those client applications. The structure of what we're talking about here is the client-server architecture, okay, with the personal computer or web browser or your smartphone being the client and the server being the back-end database or application server or web server that ties into the database, okay? Databases in today's world, especially a mobile device-driven world, are very, very, very important because, we're talking about everyday use. Everything that we touch, whether if it's Facebook, if we go to Google, any online shopping that we do, or online web browsing is driven by back-end databases that help facilitate whatever we're doing on our smartphones or our web applications or whatever it is that we're using. I would say probably 95% and maybe even more than that of anything that you do on your smartphone is driven by a back-end database at this particular point, or uses some type of database that retrieves stored data at this particular point. Okay? So let's figure out how we got here. So when we first started out using computers, and some of you may not weren't born at this particular time, but personal computers came about in the 70s and 80s, and then local area networks or Ethernet networking technology that helped create the client-server architecture started a good while ago. Okay, so notice history in regards to some of these dates in regards to Apple, IBM, Xerox, and then some of our national standards dates and stuff like that. Know those dates for test purposes and stuff like that. But this is kind of where it all started. Okay, so when we start talking about the internet, the internet originally started with ARPANET, which was a military use, a local area network used by the military, but it became very accessible in 1993. 1993 is when some of the first web browsers came out, where you can really surf, what they call surf the internet back in the day, where you can really get in contact with some of the World Wide Web resources. Okay, the bottom line is, at this particular point, when you got a computer, typically that computer had some type of software application, which was a web browser at the time. Back then it was a Netscape, and then of course on came Internet Explorer and so on and so forth. But these web browsers obviously started being able to reach companies such as Amazon, or brick and mortar stores that wanted to have a greater reach to its customers through the internet. The browsers help facilitate that. So naturally, from an economic standpoint, this expanded companies' economic bases to a wide variety of people, or a large number of people that may not have had a chance to, if they couldn't get to that store, were able to purchase stuff via the web. Obviously, early on there was challenges in regards to security. So credit card shopping and stuff like that over the web wasn't necessarily readily available to all stores as of yet. But this is kind of where where it all started. So let's see, the smartphone world. The smartphone world is kind of where we're at right now, and I don't see it obviously going away anytime soon. We're talking about the cell phone, a mobile phone, which really got into what's considered a smartphone in around 2007, 2008, because what makes a smartphone is it brought the ability to not only download apps to do specific things, but it definitely puts you on the internet and allowed you to do things that you can do on a personal computer. Okay, so the network infrastructure development in the client-server architecture, of course, helped this as well, along with our wireless communication being tied into our networks, so our World Wide Web type networks. Okay, and the same thing with tablets or iPads, which is the same thing. allows us to use different apps, the same thing that we can do on our smartphones. But the characteristics of a database, by definition in the book, the purpose of a database is to help people track things of interest to them. Data is stored in tables, which have rows and columns like a spreadsheet. So when we think of a table, I want you to think, and hopefully most everyone that's listening to this recording is familiar with Microsoft Excel. But Microsoft Excel is what they call a spreadsheet, which has rows and columns in that spreadsheet. So that's kind of how you have to think of a table, where a row and a column intersect is called a cell, and each one of those cells hold a piece of data, or stores a piece of data about something. Okay, so each row in a table stores data about an occurrence or an instance of whatever that thing of interest that you're recording the data of. Okay, so again, we have columns, we have rows. Where that column and row intersects is a cell where it will store data about the thing of interest that you want to create. Okay, so, and then the last bullet point, a database stores data, okay, the data that's recorded in each cell, and relationships. And what it means by relationships is, in this particular slide here, you see how we have an example of 3 different tables. So we have a student table, a class table, and a grade table. Okay, these tables have relationships with each other. Okay, and they have relationships with each other by the designation of what they call keys. So a primary key is a unique identifier within the table, and a surrogate key is a primary key field that's automatically assigned by the database management system. And the example here is our primary keys in the student table would be student number, the primary key in the class table would be class number, and the primary key in the grade table would be grade. Okay. One of the key characteristics of databases is how they are related, or related tables, or in one word, the relationships between those tables. So in this particular example here, notice these three tables are related by common fields, or are what's called affectionately as a foreign key. And a foreign key is a primary key in one table that is used as an identifier in another table to create that relationship between those tables. So in this particular example here, we have the same 3 tables. Notice how our grade table has changed now. So in our grade table, we added student number and class number, which formed a relationship back to its parent tables of class and student. That way, that makes all 3 of those tables related to each other. So if we wanted to pull or query information from these information, we can answer questions like what student had in the Chem 101 class had what grades, or what student in the fall term, what was the average score of students in the fall term in the Chem 101 class. We can answer those questions now because we've created relationships between the 3 tables of the data that we've stored in each one of those tables. Okay, and in the last point that we need to make from this particular side is in our grade table, what we've created is a composite key. So by definition in the book, a composite key is a primary key that consists of 2 or more attributes or columns that uniquely identify an entity occurrence, or an occurrence of that particular instance. So in this particular example, the combination of student number and class number is considered a composite key in the grade table. So you'll need both of those columns to uniquely identify each row in that table. Okay? But these are terms and concepts that we'll talk about more in the coming chapters, in Chapter 2 and Chapter 3, in regards to primary keys, foreign keys, composite keys, surrogate keys. So this is kind of just an overview. Again, in Chapter 1, we're primarily going to be using Microsoft Access, or we are only going to be using Microsoft Access. The tables and relationships that we'll be creating in Assignment 1 and Assignment 2 will look something like this when you create those table relationships. It's kind of more. The Access helps you define what those relationships are. So in this particular example here, the student table here, we've already talked about what the primary key was, which is student number. Notice that we have a key symbol next to student number that helps us identify what that particular attribute is. So it represents the primary key in that table. If you go over and look at the class table, the same thing is identified with class number and the key symbol. But if you notice in the grade table, we have two keys represented with student number and class number, and that tells us that that is a composite key, but also there are foreign keys that map back to their original tables. Okay, with grade just being just a regular column or attribute in that table to add some additional information that corresponds to a specific student and a specific class. Okay. The book uses specific naming conventions. Naming conventions in the textbook, table names are written with all capital letters. So in the book, if you see all capital letters like student, class, grade, course number, so those represent tables. Column names are written with an initial capital letter, and compound names are written with a capital letter on each word. So the example of a compound name would be class number and student name. Notice the C and the N and the S and N in those compound names are capitalized. But those are the naming conventions that the textbook uses. Now keep in mind, naming conventions in the real world are really usually specific to the organization that you're working with. But the book uses this naming convention just for our class purposes. However, that can change in any environment that you go into in regards to naming conventions. So when we talk about databases, to me this is the most important, fact of what databases do. But databases create information. Databases is more than just data, which data is defined as recorded facts and figures, or the information that we put in those individual cells. It's more than that. It's the information that we're able to create, or the knowledge derived from the data. So databases record data, but they do so in such a way that you can produce information from the data. So again, an example of that with the examples that we used, if we had a student, class, and grade table, we can produce information about a student's GPA or their grade point average. We can answer those type of questions. Okay, but I guess this is the most important concept to understand, is that databases create information. It doesn't just record facts and figures. So a couple examples of databases. A database example that you may come in contact, depending on what type of environment that you're working in. Some of the examples that they use here is like a Goldmine or an ACT. I don't know if you work in a sales environment, or Salesforce.com, those type of databases. Out of all of these examples, obviously our e-commerce applications or internet users probably serve the most users, but as you can see, databases touch just about every aspect of our daily lives as well as our working lives, depending on what area that you're in. Okay. Let's kind of break down now what the components of a database is. Okay. The components of a database consist of course, your end user, and then that end user is going to touch some type of database application that's going to be able to run and process whatever code that you're going to submit to the database management system. And then from that database management system is going to be able to manage your database, whether if you're doing create, processing, or administering the information in your database. So these are the four basic components of a database system. Now when we add SQL in, SQL is the logic or the programming code that drives the database management system. So it's again, when the end user touches that database application and he starts programming in SQL for that database management system, this is kind of where SQL fits in the component structure, okay? Because SQL is going to drive the creation, process, and administration of your database data, okay? We've already talked about applications. The applications again are the programs that customers touch to that, or excuse, not customers, but the end user uses to work with the database management system. The database management system creates, processes, and administers the database. And then SQL, which stands for Structured Query Language, is an internationally recognized standard database language that is used by all commercial database management systems. Okay, so all that to say is that once we get a good understanding of SQL or structured query language, we can take those skills and we can use those skills in any type of database management system and be able to, again, create, process, and administer any database. Okay, so this is the end of part 1.